Hey, hello there, and welcome back. So I just finished recording the solution for day 14 of Advent of Code, which is about simulating some grains of sand falling into rock. But I really wanted to visualize these things somehow, so I wanted to give this a try. If you haven't watched the video, maybe this code won't make any sense, but wait, well, this is just a code that is simulating, it's parsing the map of the input, so it's basically solving this puzzle. Oh, we can go back to the Advent calendar, day 14. Oh, look at the waterfalls here, nice. So yeah, it's doing this sort of simulation where you have some rock paths and then dropping grains of sand here represented by O letters. And yeah, look at that, it's quite pretty. So I want to see this is in action, like moving. So maybe we can do that by printing the state of the map after each grain of sand is dropped. So here we have like the dropping of the sand grains for part 1 and then for part 2. So I guess we could insert some like print map here, and we're gonna pass a reference to the map, and we can generate this function, and this would be actually a reference to, I declared a type for this map, which is a vector of vectors of tiles, and it's gonna return nothing. And we're also going to print the map down here. So how should we do this? I guess we could go for each row in the map. Yeah. Do we need to say iter? Yes, otherwise it's going to call into iterator, I think. I'm not sure though if this is okay. Yeah, I think it is. It's going to consume that reference. But anyway, let's generate the line that we want to print. I had written this code for the solution, but I deleted this. So let's write it again. Let's line should be, well, type string, should be row, iterates, and map each of the tiles, and we are going to generate a character for each of the tiles. So let's say if the tile is air, let's print space. If it is rock, let's print a hash map, and if it is sand, let's print an O, just like in the puzzle description. Although here I'm not using dots because I think it's nicer to see empty space. And I guess we have to collect this. So since this is an iterator of characters, this can be collected into a string, so that's good. And we can print line this. So print the line, and let's actually then print another new line to separate the output of one iteration from the next one. And maybe we can print it at the beginning. Sure. And we should wait some time to see this animated. So is there some std, let's see, sleep? Well, there is a deprecated sleep ms and std thread. So what did I actually import here? Oh, nothing. Let's see. Yes, import thread sleep. And what does this return? Or what does it receive? A duration. Okay, can you give me an example? Time duration from milliseconds. Okay. Well, I guess we could do duration. Yes, from millis. And let's wait, I don't know, 50 milliseconds between each iteration. Okay, let's see what this does. Oh, here we have the printing of the... This was the field map for part 1, and then we draw the floor. Actually, these maps now have 1,000 characters in size, so let's get to the usual font size. How many characters can I print here? I did a bunch of enters here to not have my face, like to see how wide we can print. Let's maybe print. I want to see how many characters we can fit on the screen at the minimum font size. So let's do put hash times 100, 500. So if we do this and we decrease the font size, okay, we can print 500, but not much more. It doesn't go any lower than this. We won't also see anything if we go lower. So let's see, 700 maybe. Oh, 700 is already a bit too long. Let's see what happens with 600. Okay, we can print 600 and a bit more. So let's not print the, let's go to 0. Let's not print, we are using a map of 1000 units wide. Here I don't know where that is. When we are parsing, yes, we are hard coding the width of the map to be 1000. So let's get these vectors, let's slice them to have 600 characters, so we can start from 200 and go up to 800, I guess, and that should be 600 characters. And let's see if that's easy enough to see all the sand droppings. And actually, for the sand, maybe I'm hesitant to use the O sign here. Maybe a dot will look better, but I don't know. Let's see. Let's see what happens when we run cargo run 14, and let's decrease the size to the minimum. Let's go. Oh, okay. So this is the map. Where is the sand? Oh, the sand is filling here. You can see it. It's also flashing a little bit because of the printing, but you can see the sand actually here. It's flowing. Look at it, but it's not very visible. So, but this is so cool. Let's use a more readable character. Maybe let's go with the O's here, and let's not wait so much. Maybe 20 milliseconds. Although maybe now it will flash more. I don't know. Yeah, it is flashing more because it's too much for the screen. We're actually, can we print a clear screen code? How was this thing? Terminal clear screen code. I don't remember how this thing is called, like ANSI characters, something like that. Rust print ANSI codes, escape codes. Yeah, it's clear, but Does not seem to support octal, blah blah. Instead, you can use hexadecimal escapes like this ugliness. Sure. Gist is useful. Okay. Control key, yes. Sure. So, how do we clear? Isn't there a sequence to clear the screen? I thought it was. I know that you can use this to render colors and stuff like that, but let's see. Terminal escape sequence to clear screen. $27. No, this is the escape character. Yeah, I know that clear exists, but console code. Oh, is it just C? So we print the hexadecimal 1B and then C to clear. Yeah, okay. Well, let's try this. So before, instead of doing println here, let's println the clearing command or escape sequence. Let's see what happens now. Well, it is flashing, but you can see the thing filling here. It's a bit too flashy though. But it's also really nice. Oh man, this is kind of cool. How could we make this not be so flashy? Oh, maybe we don't do println like this. Maybe we can accumulate all the lines and then print them all at once. So let's do that. Let's do let lines be no, actually, so let output be string new, and here we are just going to do output push string this line, this surely needs this to be mutable, and this probably needs this to have, yes, okay. We probably don't even need to collect push, like if we do extend I wonder. Wouldn't you like this? Yeah, sort of liked it. So we're going to extend with that and then output push a new line. Okay, and let's remove this, and now let's print println, but actually we can just print because we put a new line in the end. Print the output all at once. Maybe this will get rid of the flashing. Let's go. And it didn't. maybe it's worse now. So I guess this is because of the this duration. If we make it 50 milliseconds and maybe we don't print maybe we can do something like this. Print the escape to clear and then write all the inputs. Let's see what happens now. Okay, with 50 milliseconds it's much less flashy. So we can see this thing feeling, oh, it's very pretty. Maybe we can make the size a bit bigger. Yes, you can see it feeling there. And then it's going to feel this other thing. Oh, look at that. It's so nice to see. This is really cool. I do want to see like maybe the rock being a different color and the sand being yellow. So can we do that maybe? Where was this? I got too many terminals open. Color escape codes, yes. Yeah, okay. I don't want to do that. Erase the display. Oh, look at this. There's the 2J and interesting stuff also. I wonder if this like 2J would be like the, does it mention the escape C, this thing? C? No, C. I do wonder if what I'm reading here is actually what I want to read. But this erase thing, erase and display, this escape 2J, can we make it like here? 2J? Would this work? Now it's not flashing much. I don't know if this made any difference or if it's doing something. It's just printing the output. No, actually, yeah, it's just printing the output, but it does look non-flashy, but I guess it's because we changed this here. Let's see, 25 milliseconds, what happens now? Okay, yeah, that's not too bad. Let's try to add some colors to this. So the escape sequence was this thing, we can use it. Let's go back to this. So air can be blank, of course. Let's make the sand be some color. Oh, actually here we would need to we would need to make it a string, I guess. So yes, let's return strings from here. Sure. Do you still like this? If we run it like this, yeah, you still like it with strings. But here, let's say the sand is this, and let's write a background color. So if we do 13M style to bold, red foreground. So let's try it with this and see if it makes any sense. Red foreground. So this should be red sand. No, because we are setting that and then it's overriding for everything. So we should probably reset it when we are printing the stone. So colors, reset all modes. So 0M is reset, so let's do that also. When we print the output, let's reset the console to not leave it like all screwed up. Here, perfect. And let's also bold mode, blah blah, color codes, foreground, background. So I guess we could print the background as let's use white for, so this is 47. We don't need, I think, bold or whatever, but okay, no, 47 for the rock. And let's just print a space, because this is just, yeah, we just care about the background. And let's cyan, magenta, yellow, 43 for the sand. I guess the rock could be black. Let's see how that looks. Although I do have a black background, so let's see. Run now. We're just seeing the, oh, look at that. We're not resetting things. We should also reset it for the air. So let's print this for the air. And let's not do it in black for, I guess rock could be magenta, why not? Look at this beauty. Yes, look at it go. Oh man, this is kind of pretty. Kind of ASCII arty kind of thing. It's also quite satisfying to look at. Look at the sand feeling like it's such a simple algorithm, but it works really well for you know, as a satisfying thing to look at. So this, I guess, is gonna get filled. Oh, look at it go to the top. So this will prevent, it will raise to the top here and it will start flowing the other way around. Oh, that will be very nice. But this wait time is a bit, how much are we waiting? 25 milliseconds. It's not flashing now, but well, here it goes. Well, there was a flash there. So this will start now flowing here. Oh, look at that. This will fill this thing. Oh man, this is so good. What a nice idea for a puzzle this was. Oh, and then we are going to draw the floor, because this is all the part one. But then after all of this gets done and one of these grains falls to the void, we are going to add a floor of magenta. And oh, I want to see that. Let's go. Oh, there is the floor. And now it's just filling. This will fill everything, dude. I don't know how it will end up looking. But it's really nice to look at. Oh, look at this inverted triangle here. I guess we are going to have quite a few inverted triangles, actually. We can, I guess, kill this and see the end results. So we can do a print map at the end and remove this one. And well, let's close this and run this thing again. And this is the end result. Look at this. Oh, that's really cool. It's a pyramid of sand, and a very nice pattern to look at. We'll actually probably take a screenshot of this. Yeah, grab the whole screen and screenshot it. Very nice. That could be the thumbnail for this video. Well, anyway, that's what I wanted to do, and this was very satisfying to see. So I hope you enjoyed, and see you next time. Bye bye.